so now we're just going to look at a few more examples. So again, start by writing out the equations. Sorry about this. Labeling them 1, 2, and 3. So that way we know which ones we're working with. So the first thing we want to do is look at all of the variables and see which would be the easiest to eliminate from all three equations. So again, you can choose any of them, x, y, or z. I think z would be easiest because they all have a coefficient of 1. So I have to use 2 of them at a time. So I'm going to use 1 and 2 first. So I'm going to do 1, which is 2x minus y plus z equals 4. And I'm going to use equation 2, which is going to be x plus 3y minus z equals 11. Okay, now the z's have the same coefficient. They're both 1, and they have opposite signs. So this is fantastic, and we're just going to add straight down. So 2x and x is going to give us 3x. Negative y and 3y is going to give us 2y. The z minus z is going to get eliminated. And then 4 and 11 is going to give us 15. Okay, I'm going to circle this because I'm going to come back and use that. Okay, I did not use equation 3 yet. So what I'm going to do is I'm going to use equation 1 and 3 because if I want to eliminate the same variable, which is z, I can see that 1 and 3 have opposite signs. So I don't have to do any multiplication to change anything. So I'm just going to use those as is. So I'm going to use equation 1 again. So 2x, minus y plus z equals 4. And I'm going to use equation 3. Now, if you wanted to use equation 2 and 3, that's also fine. You're just going to have to multiply one of the equations by a negative 1 to get the z to have opposite signs. Okay, so now I'm using 1 and 3. The z's have the same number coefficient of 1. They have opposite signs. So we're going to go ahead and just add this straight down. 2x and 4x is going to give us 6x. Negative y and y, so that's going to get eliminated. We didn't try to eliminate the y, but it ended up happening, which is okay. Z minus z is going to cancel out as well. So when this happens, 4 and 14 is going to give us 18. Sometimes we luck out and multiple things will cancel out, and then we can just solve for a variable without having to do another step. So here I have 6x is 18, so I'm going to divide by 6. So I end up getting x is equal to 3. So without having to create a second equation and do a system with the 2 new equations, I already solved for one of the variables. So now what I'm going to do is I'm going to take the x that I got and I'm going to plug it into that new equation I created. So I'm going to solve for y. So I'm going to have 3 times x, which is 3, plus 2y equals 15. So I'll have 9 plus 2y equals 15. I'm going to subtract the 9. 2y is going to equal 6. I'm going to divide by 2. So I'm going to get that y is equal to 3. Now that I have x and y, I'm going to go to any of the initial 3 equations. So I'm going to use equation 1 just because. So I'm going to have 2x is 3, so we're going to plug that in, minus y, which is 3, plus z equals 4. So 2 times 3, we get 6 minus 3 plus z equals 4. So we're going to get 3 plus z equals 4. Subtract the 3, and we're going to get that z is equal to 1. So now we have x, y, and z. So our answer here, again in alphabetical order, will be 3, 3, 1. Okay, so that one was a little bit easier because we were able to cancel out 2 variables at one time. Had you chosen to use equations 2 and 3 instead of 1 and 3, maybe that wouldn't have happened. If you decided to get rid of the x's instead of the z's or the y's instead of the z's, again, that might not happen. So it's just kind of works out with whatever you decided to use. All right, so let's look at another one. So again, first thing that we're going to do is label our equations 1, 2, and 3. So here's 1, here's 2, and 3. So I'm going to look at all of these again and see what variable we should eliminate. Again, any of them is fine to eliminate. I'm going to go with the z's because 2 of them have a coefficient of 1 and 1 of them doesn't. So that means I won't have to do too much multiplying of numbers. So I'm going to do 1 and 2. Let me change my line here. So I'm going to do 1, which is negative x plus y plus 2z equals 7. And I'm going to do 2, let's say. Okay, now the problem here between 1 and 2 is that, let me write this out because I can't write and talk at the same time. So the problem here is that if I want to eliminate the z's, they're not the same. So if they're not the same, what I have to do is make them have the same number. So if I want them to cancel out, they're both going to have to, in this case, be 2, and they're going to have to be opposite signs. So what I'm going to do here is I'm going to multiply the second equation. I'm going to multiply this whole equation by negative 2. Okay, by multiplying it by negative 2, my z will then have the same number and opposite signs. So the first equation, I'm not going to do anything to the first equation. I'm just going to keep it exactly the same. So negative x plus y plus 2z equals 7. The second equation, that's when I'm going to multiply every piece by negative 2. So 2x times negative 2 is going to give me negative 4x. 3y times negative 2 is going to give me negative 6y. Z times negative 2 is going to give me negative 2z. And then 1 times negative 2 is going to give me negative 2. So now that my z's have the same number as the coefficient and opposite signs, I'm going to go ahead and add this straight down. Oops, so add that. Negative x and negative 4x is going to be negative 5x. Y and negative 6y is going to be negative 5y. 2z and negative 2z, that cancels out. And then 7 minus 2 is going to give us positive 5. Okay, so I'm going to circle this because I'm going to come back to it. Okay, the next thing I'm going to do, I have to use equation 3. So I can choose to use 1 and 3 or 2 and 3. So I'm going to choose to use 2 and 3 because the coefficients are already the same number, but I'm going to have to multiply by a negative for one of them. So let's just use the two equations we're going to use. So 2x plus 3y plus z equals 1, and I'm going to use equation 3 as well. So equation 3, we have negative 3x minus 4y plus z equals 4. Okay, my z's have the same coefficient number of 1, but they have the same sign. So in order to give them the opposite sign, I need to multiply one of these by a negative 1. So I'm just going to multiply the first equation. Actually, let me rewrite this so it doesn't look as bad. So we're going to multiply it by negative 1. So the first equation here that we're using, which is equation 2, I'm going to multiply negative 1 to every term. So 2x times negative 1 is going to be negative 2x. 3y times negative 1 is negative 3y. Z times negative 1 is negative z. And then 1 times negative 1 is negative 1. The second equation, I'm not going to do anything to that. I'm just going to leave it exactly the same. So negative 3x minus 4y plus z equals 4. Okay, now I have the z's that have the same exact coefficient number, and they do have opposite signs. So now I'm going to go ahead and add these straight down. So negative 2x plus negative 3x will give me negative 5x. Negative 3y and negative 4y gives me negative 7y. The negative z and the positive z are eliminated. And then negative 1 and 4 is going to give me positive 3. Okay, so I'm going to circle that as well. That's my other new equation. So now what I'm going to do is stack those two new equations and eliminate a variable there. So I'm going to stack up negative 5x minus 5y equals 5 with the other equation I created, which is negative 5x minus 7y equals 3. So I can see that the x's are probably good to get rid of here because they have the same number coefficient, but the signs are not opposite, they're the same. So what I'm going to do is multiply one of these by a negative. So I'm just going to multiply the first equation. Let's put a negative 1 in the front. So I'm going to multiply negative 1 times negative 5x, which is positive 5x. Negative 1 times negative 5y is positive 5y. Negative 1 times 5 is going to give us negative 5. The second equation, we are not doing anything to that. We're just going to leave it exactly the same. So we have negative 5x minus 7y equals 3. So now I can go ahead and add these straight down because my x's have the same coefficient number and opposite signs. So 5x and negative 5x will eliminate. 5y and negative 7y gives me negative 2y. Negative 5 plus 3 is going to give me negative 2. So now when I divide by negative 2, I will get that y is equal to 1. Okay, now that I know that y is equal to 1, we're going to go back up that ladder, right? We went all the way down the ladder. Now we have y is 1. So we're going to go back up to either of the two circled equations. So I'm just going to use the purple circled equation, and I'm going to plug in the 1 for y, and I'm going to solve for x. So I'm going to do negative 5x minus 5 times 1, because that's our y, equals 5. So negative 5x minus 5 equals 5. I'm going to add 5. Let's see if I can not make this too small. Oops, there we go. So we get negative 5x is equal to 10. We divide by negative 5. So x is equal to negative 2. So now that we have y and we have x, we're going to go back up the ladder now to one of the original 3 equations. Okay, it does not matter which equation we use. I am going to use the first one. So I have negative x, and x is now negative 2, plus y, which is 1, plus 2z is equal to 7. So a negative negative becomes a positive 2. So we have 2 plus 1 plus 2z equals 7. So 2 plus 1 is going to give us 3 plus 2z equals 7. We're going to subtract 3. We're going to get 2z is equal to 4, and then we're going to divide by 2. And we're going to get that z is equal to 2. So we have our x, we have our y, and we have our z. So now we just want to write our final answer, and we're going to do that as an ordered triple in alphabetical order. So x is first, so negative 2, comma, the y value, which is over here, which is 1, and the z, which is 2. So negative 2, 1, 2 is going to be our solution to this system.